Hi, in this video we're going to talk about the graphs of trigonometric functions. Now you'll quickly remember that when you have a right angle triangle and one of the angles, which is not the right angle, right, let's call this as theta, right, the arms of this angle, namely AC and BC, right, the arms of this angle and the side, which is just across this angle, has a relation, right? So we were calling these as trigonometric ratios, and we were saying that according to the angle chosen, in this case it's this one, right? This is the adjacent side, that's the opposite side, and always the side across the 90-degree angle is hypotenuse, right? So we remember all those. If we were to choose this angle, which we call as alpha, then this would be opposite because it's across the angle alpha, and this is adjacent, right? These will change, but hypotenuse never changes as it is across the 90-degree angle. And what happens is we defined, let me get rid of these alphas, the blue ones, right? We defined sine theta, for example, to be opposite over hypotenuse, right? So that was the ratio. Cosine theta as adjacent over hypotenuse, and there is also the tangent theta. This is opposite over adjacent, right? So these fractions, these ratios, and the angle has a relation. Now, just because there is this relation in between, when we look at it closely, we find out that this is actually a function. So when we call this as y equals sine theta, or y equals cosine of x, y equals tangent a. So as you can see that these are just dummy variables. We don't stick to any one of them. We can change these, right? But these three, and many more, actually there are more trigonometric functions than these. These three are actually trigonometric functions, and when we talk about functions, we can also talk about their graphs. So now if we look at some certain values, some certain degrees, right, 0, 30, 45, 60 and 90 degree angles, right, the sine of these angles start with a 0, and then we have 1 over 2 for sine 30, root 2 over 2 for sine 45, root 3 over 2 for sine 60, and 1 for 90 degrees. Whereas the cosine repeats these values from reverse. Cosine 0 is 1, cosine 60 is root 3 over 2, cosine 45 is the same as sine 45, cosine 60 is like sine 30, right? And cosine 90 is 0. Now, from here we can conclude that sine theta is the same as cosine 90 degrees minus theta. You can see that sine 30 right here and cosine 60, which 30 and 60 adds up to 90, right? So they have the same value. Now, as per tangent, it's interesting to find out that basically a tangent function, y equals, let's say, tangent theta, is actually the ratio of sine theta over cosine theta, right? So when you divide sine values by cosine values, you find the tangent value. So 0 divided by 1 is 0. 1 over 2 divided by root 3 over 2 is, well, if you do that, you end up with 1 over root 3, which is root 3 over 3, right? When you rationalize the denominator. So that's going to be root 3 over 3. And root 2 over 2 divided by itself is 1, right? Root 3 over 2 divided by 1 over 2 will end up with tangent 60 to be root 3. And this is interesting. 1 divided by 0 is undefined. So we don't have a value for tangent 90 degrees. It's undefined. You don't need to memorize this table, but it's good that if you know these values, the specific values like sine 0, sine 45 and so on, it will be helpful for you to speed up your calculations actually. Now, when we plot these values on the xy plane, we get the sine graph to appear like this. Now we have a few things to notice. This looks like waves, right? And this goes on forever on the x-axis. Now what we need to notice, very important, is that the wave, the sine graph, as you can see, well, if I draw a proper line, it is in between 1 and minus 1. This never changes. You cannot see a sine theta function, a sine function, to go beyond 1 and minus 1. It always oscillates, let's say, between 1 and minus 1, unless it is stretched or translated or transformed in another way. Right? We're going to talk about that later on. But sine function is in between y equals 1 and y equals minus 1. These are the maximum and minimum values for sine. Certainly you can see that sine 90 degrees is 1, sine 270 degrees minus 1, and sine 450 degrees is again 1. You can see that sine theta is 1 when theta is 90 degrees, 450 degrees, and it goes on forever. But you have to notice that this sine theta equals 1 values repeat in every 360 degrees, which is what we call as a period, right? And this happens for each value in the sine theta graph. You can see that sine theta is negative 1 when theta is negative 90, 270 and so on. This is also 360 degrees in between if you take away negative 90 from 270, right? And you can see that sine theta equals 0 at the origin, and it is again 0 in 360 in the sense that, I mean, this is also 0 of course. What I'm trying to say is that it again shows the same direction within 360 degrees change, which we call again as a period. Now, cosine function is somewhat similar. It looks as if it is translated by 90 degrees. Now remember, the sine function was, well, let me draw the lines first. It's in between 1 and minus 1, as you can see. Cosine function behaves the same way, right? However, remember the sine function was somewhat like this. It was 1 at sine 90, so it was like this. It was 0 in 180, right? It was going like this. So basically, it is a translation of 90 degrees, right? In, say, the left-hand side. So cosine function is similar. It oscillates between 1 and minus 1, but the values that cosine function get for 1 and minus 1 are different, okay? There's a 90 degree difference between them. But you can see that the values of 1 is again 360 degrees, and here values of -1 is 360 degrees. So each 360 degree addition gives you the minimum points, or in general, any point on the cosine function repeats itself 360 degrees later. Alright, that's what again we call it as the period of the cosine function. So basically, sine and cosine functions have the period to be 360 degrees. Now when it comes to tangent function, if you plot the points and everything, you get quite a different graph, right? Now we found out that some values in tangent function is undefined. Well, for tangent 90, right, it was undefined, so this is actually the vertical asymptote, right, for the tangent function, and it repeats itself. You can see that we have vertical asymptotes here, and this is also a periodic graph because this curve repeats itself for forever, right, in each direction. And the period is 180 degrees, as you can see. It's from -90 to 90, 90 to 170, right? So the period of tangent function is 180 degrees. And the tangent function graph looks like this. It looks as if it is a cubic function, but it isn't, of course. Right. So these are the three basic trigonometric functions. And at this moment we have nothing else to work on, right? We're not going to draw graphs of these functions as we did in cubic functions and reciprocal functions, because when we start doing that it becomes transformations. So we're going to do this in the transformation bit, but at the moment I want you to take note of each of these functions and their properties, like the name of the function and then its period, right, and so on. You can also write the maximum and minimum values. This is only valid for sine and cosine, and I also would like you to draw the graph of each of these three functions on your books. Thanks for watching.